Good day, everyone. My name is Godfrey Naane. I'm going to present to you the effects of biochar amendments on soil aggregates for sustainable agriculture. Biochar is a charcoal material produced from pyrolysis of biomass in the absence of oxygen. It is used as a means of carbon sequestration, and it may be a means to mitigate climate change, increase fertility of acid soils, and also provide protection against soil-borne diseases. The project came about after realization that the country's past agricultural practices had a long-term negative effect on the environment. Agriculture in particular has been characterized by intensive use of chemical fertilizers and other external inputs, as well as high-level use of petroleum products like gas emissions. These practices contributed a lot to unsustainable use of agricultural soil, which led to global warming. Thus, there was a need to start a project in order to develop a system in which some organic matter is left in its original form as forest residues, some is burned conventionally, and some is converted into more stable carbon in a form of biochar. In this project, other fertilization strategies like applying mixed fertilizer in other treatments are involved. This is the locality of the project, that is Kgora Resource Center in Mahikeng, whereby charcoal dust is applied and incorporated into the soil prior to planting. About 5 tons per hectare of biochar is recommended. These are some of the images from the project. Some of the remnants of biochar incorporated in other treatments can be seen on that arrow. Objectives. The main objective is to investigate the potential use of biochar as a soil amendment in a typical maize field to promote sustainable agricultural practice. Short-term objectives are to determine the effect of biochar on grain yields during the growing season and in the normal harvesting process, to determine the effect of biochar on nutrient levels in the soils amended with biochar, and also to determine the effect of biochar on pH levels of the soil. The long-term objective is to demonstrate how implementing biochar systems could enhance fertility levels and also carbon sequestration in the soil. Methods and fertilizer practices. The first treatment, maize control, that is maize without any fertilizer or biochar. The second treatment, maize fertilized with mixed fertilizer, that is 120 kilograms per hectare of fertilizer. The third treatment, maize with recommended fertilizer plus biochar, that is 120 kilograms per hectare of fertilizer plus 5 tons per hectare of biochar. The fourth treatment, maize with biochar alone, that is 5 tons per hectare of biochar. The fifth treatment, maize with half recommended fertilizer and half recommended biochar, that is 60 kilograms per hectare of fertilizer, and 2.5 tons per hectare of biochar. The trial is arranged in a randomized complete block design, which is replicated 3 times and consisting of the following main treatments: maize in monoculture, fertilization of maize, and maize with the biochar. Sampling dates were 2018, 2019, 2020, 2021 season. That is, the results which will follow are from only 2 seasons. According to the results of 2018-2019 season, maize with NPK had higher yield of 2.2 tons per hectare, followed by maize with NPK and biochar, that is a recommended fertilization and recommended biochar application, with the results of 2.1 tons per hectare. Maize without any fertilization or any application of biochar had 1.9 tons per hectare, and maize with biochar had almost the same results. Average results on all treatments is 2 tons per hectare, and the average yield estimate for Mahikeng on maize is about 2.2 tons per hectare under the average rainfall of 500 millimeters per annum. Second season 2020-2021, maize with NPK and recommended applications had a higher yield of 2.2 tons per hectare and 2.1 tons per hectare respectively. Maize monoculture had a lower yield of 1.6 tons per hectare this season, and the average yield is 1.9 tons per hectare. Conclusion: the treatment of maize with NPK yielded higher results as expected. However, combination of mixed fertilizer and biochar had slightly higher yields for both seasons. The build-up of the fertility status of the soil, as well as pH levels for both seasons, are not included in the results due to non-availability of resources to test or analyze soil samples. The analysis of biochar dust for composition of elements within this parameter or measurable factor was also not done. The role or impact of charcoal dust or biochar on maize growth and yield is still to be investigated as research progresses. Let me take this opportunity to thank you all. Ke a leboga.